and PLAR Math. So today we are beginning week 4 of classes, and so after this week, 2 more weeks of classes before the Christmas break. So of course that means you need to get your work done and get it submitted for marking. To participate in classes, you can use radio or Zoom. The instructions are in your study guide, or you can contact your DEC or me to see how to join classes. All PLAR Math students are welcome to attend classes, so it doesn't matter how you signed up for PLAR Math, if you signed up IL or if you signed up for Radio Zoom, all PLAR Math students are welcome to attend the classes. To contact me, you can use email, phone, or send a message on Facebook, whatever works best for you. And the PLAR English classes from last term are still available on YouTube. So if you go to B. Osman Wassa for YouTube, you will find my playlist, the PLAR Math and the PLAR English. Or you can use the new Wassa Distance Education Center YouTube channel and find the PLAR Math and the PLAR English playlists there as well, as well as all of the other courses offered through Wassa on Radio Zoom. Okay, so either way works. The PLAR Math classes will be updated as I record the new classes, but the old classes are still there from last year, from the last time I taught the math. So if you are working ahead of where we are in class, you can go there to watch the videos from last year. Just a reminder, that students who did not finish your PLAR English in Term 1A, you can still continue to work on the key questions in Term 1B. You're not withdrawn, so you apply for PLAR once a year and then you're in for the whole year. Once you finish one subject, you just move on to the next one. It doesn't, like I said, you're not withdrawn, so you're just in there. You stay in once, you apply once and you're in there for the year. Just a new reminder for anyone who doesn't know, all PLAR students this year have the option of writing the culminating activity instead of doing the lessons and the key questions, even if you've already completed and submitted some of the key questions. So even if you've already started, you've done lesson 1 or you've done a few questions in lesson 1, you can still opt to write the culminating activity instead of finishing the lessons and key questions. And if you pass the culminating activity, then you get your English credits or math credits, whatever subject it is. You don't have to finish up the key questions, and then you just move on to the next subject or the next phase of your education. If you're not successful with the culminating activity, then you do have to do the lessons and complete the key questions, and then you get the opportunity to write another culminating activity after all of the work is done. Okay, so just a reminder that there are 2 types of questions in your lessons. There are the support questions and the key questions. The support questions are there for you to get practice before attempting the key questions. Most of the support questions are the same format, same style, same type of question as the key questions. So if you do those support questions first, get a little bit of practice so you know what you're doing, then you have a better idea when you do the key questions. The answers to the support questions can be found near the end of the lesson right before the key questions. So once you do the support questions, go to the end of the lesson and you will find the answers to the support questions. If you're doing well with the support questions and you're getting all or most of the support questions correct, then you move on to the key questions. Okay, the key questions are the ones that you submit for marking. They're the ones that have the marks. Okay, so make sure you submit the correct questions. Ways to submit your work. First way, of course, is to give it to your DEC, and then your DEC will get it out to us here in Sioux Lookout. If your learning center is closed or you don't have a DEC, your DEC is away, then you can submit your own work. And there are several ways of doing that. If you have access to a scanner, for example, at work, then you can scan and email your own work. Send it to studentwork@nnec.on.ca and make sure to CC it to me. Or if you have access to a fax machine, you can fax to our toll-free fax line. If you're submitting your own work, be sure to write your name, the subject, and your teacher's name on your work so that when we get it, we know who sent it. Otherwise, we can't return it to you. So make sure your name is on there. If you don't have access to a scanner or a fax machine, then you can use your smartphone. With your smartphone, you can either take photos of your work or you can scan your work and then email it to that same email address and CC it to me, or you can send it using Facebook Messenger. Also, if you are in Sioux Lookout or you come to Sioux Lookout fairly often, then you can use our outdoor mailbox that's located in the parking lot at the side of the building facing the post office, or you can just knock on the door and give it to whoever answers the front door. You can also use Google Docs to complete your work, and then you can send me the link. Okay, so share the link with me and I can get your work that way. And then you can also use Google Classroom to complete and submit your work. Okay, so lots of ways to get your work out to us, even if you don't have a DEC in your community or your DEC is away. Okay, just want to mention as well that we do have draws at WASA. So at the end of every term, including term 1B, there are 2 student draws. One is for students who earned a credit, and one is for students who submit work. So for every lesson you submit to us, your name gets entered into a draw. So if you submit 5 lessons, then you get 5 entries. And if you submit all of your lessons and you get your credit, then you get entries into the work draw and the credit draw. So you have the opportunity to win 2 prizes. We're not sure what the prize is going to be for this term yet, but once we know, we will let you know. Also, for this term before Christmas, students who have already registered will have the opportunity to win the Community Student Learning Center draw, which will take place on December 16th. One student from each community can win a $200 holiday gift from a local store. So your northern store or whatever your local community store is, or if you're in Sioux Lookout Fresh Market or whatever, we will contact you to find out where you would like to have that gift card or that gift from. Okay, so and that's just for students that are registered already for this year. Okay, so a review of what we talked about last class. So last week in class, we started talking about fractions. We're still working in lesson 1, and I believe I've mentioned before that lesson 1 is a very important lesson because it's the foundation of what we are going to be doing in the remaining lessons. So we talked about integers, negative and positive integers, which is something that we're going to be dealing with in the other lessons, and the same thing with fractions that we started talking about last week. We will be working with fractions throughout the lessons as well. So it's very important that you understand and can work with integers and fractions. Excuse me. So last week on Thursday, we started talking about fractions, and we started talking about like and unlike fractions. We talked about different types of fractions, and we talked about like and unlike fractions. So fractions with the same denominator are called like fractions. Doesn't matter what the numerator is, but if the denominator is the same, they are called like fractions. Fractions with different denominators are called unlike fractions. So in these examples, 1/3, 1/4, and 4/6, they have different denominators, 3, 4, and 6, so they are unlike fractions. So then after we talked about the different types of fractions, we talked about how to add and subtract fractions. So if the fractions are like fractions, it's pretty easy. All you have to do is add or subtract the numerator, so the numbers on top. So if your denominators are the same, like in this example, 5/12 plus 4/12, with the same denominator, so now all we have to do is add the numerators. Okay, so it's the same thing as having 5 plus 4, which is what we're doing, and the denominator will stay the same. We don't add the denominators. We don't do 12 plus 12 is 24. That would be wrong. So we keep the same denominator, but we add the numerators. So 5 plus 4 is 9, and the denominator is 12, so 9/12. Now we have our answer, but we always have to check and see if we can reduce the fraction. So is there a number that will divide evenly into 9 and 12? So 9 is 9 times 1 or 3 times 3. 12, so I'll do it this way. So 9, 3 times 3. 12 is 3 times 4. Okay, so we've got 3 that will divide evenly into 9 and 12. So we can do 9 divided by 3 is 3. 12 divided by 3 is 4. So our answer, our final answer, our reduced answer is 3/4. Okay, so 5/12 plus 4/12 is equal to 3/4. Okay, to add or subtract unlike fractions, the first step is to make the denominators the same so that numerators can be added just like we do for like fractions. So with fractions that have different denominators, we have to first of all find a common denominator. So we have to ask which number will 8 and 6 divide into evenly. So there's two ways of doing this. One way is to simply multiply the denominators together and then multiply the numerators by the opposite denominator. Okay, so that means 5 times 6 over 8 times 6 plus 5 times 8 over 6 times 8. So we're multiplying top and bottom by the opposite denominator. So 5 times 6 is 30 over 48 plus 40 over 48. So we have the same denominator. So then we just add the numerators. 30 plus 40 is 70 over 48. Now, we have an improper fraction because the numerator is bigger than the denominator. So now we have to change this to a mixed fraction. So 48 will divide evenly into 7 one time. 70 take away 48 is 22. So we have 1 and 22 over 48. Now we need to see if we can reduce the fraction part of our answer. Okay, so 22 48ths. So 22 is, the factors for 22 are 2 times 11. And the factors for 48 are, well, there's 6 times 8, there's 2 times 24, so we'll divide both of them by 2 because I know they're divisible by 2. So 22 divided by 2 is 11, 48 divided by 2 is 24, so our answer is 1 and 11/24. This is our final answer. Okay, don't forget to include that whole number in your answer. Okay, so that's one way of doing that problem. So the second way, I'm going to do it down here, it says step 2 is add or subtract the numerators, which we already did here. So the second way of doing it is to see if there is a number without multiplying by the opposite denominator that's smaller than 48. So I know that 8 and 6 will both divide evenly into 24. So I want to make my common denominator, instead of having 48, which is a big number, I want to make it 24. So 5 times 8, I'm I'm going to find the equivalent fractions, and remember, to find an equivalent fraction we have to multiply or divide by the same number, top and bottom. So 8 times 3 is 24, so if I multiply 8 times 3, I've got to multiply the numerator by 3 as well. So 5 times 3 is 15, 3 times 8 is 24. So 15 24ths is an equivalent fraction to 5/8. Now 6, I know 6 times 4 will give me 24, so I also have to multiply my numerator 5 times 4. 5 times 4 is 20 over 24. So I get 15 24ths plus 20 24ths. Now I'm going to add them. 15 plus 20 is 35 over 24. Improper fraction again, so I have to change it to a mixed number. 24 goes into 35 one time evenly, and 35 take away 24 is 11 24ths. So I got the same answer here as I got up there, but I did it slightly differently. I didn't have to do the step of reducing because it's already in lowest terms. Okay, so depending on which way you do it, you might have to reduce or simplify, or you might not. So if you find the least common multiple for the two numbers, 6 and 8, then you don't have to reduce, or you might not have to reduce. If you just multiply the denominators, the fractions by the opposite denominator, then you will have to reduce. Okay, so those are the two ways of adding or subtracting unlike fractions. So there's a lot of steps involved, so you need to take your time. Don't try to make it faster by trying to do it in your head and then messing up. So you might say 8 times 3 is 24 and then forget to multiply your numerator by the same number, and you end up with 5 24ths. Well, that's a completely different fraction, which means your answer is going to be wrong. Okay, so take your time, be very careful when you're doing this. Okay, so that's what we did last week. So we've done adding, subtracting, multiplying, and dividing integers. We've looked at what fractions are. We've looked at reducing fractions. We've looked at adding and subtracting fractions. Today we're going to finish up lesson 1 looking at multiplying and dividing fractions. So in your lesson, beginning on page 26 is information on multiplying fractions and an example showing you how to do it, taking you through the steps. Then on the next page is support question number 10. Take your time. Once you're done that, check your answers at the end of the lesson. Okay, so multiplying and dividing fractions. Okay, so for multiplying fractions, there are 3 simple steps. So step 1 is multiply the numerators from each fraction by each other. So the numerators, remember, are the numbers on top. The result is the numerator of the answer. Step 2, multiply the denominators of each fraction by each other. And the numbers on the bottom are the denominators. The result is the denominator of the answer. Step 3, simplify or reduce the answer. So with multiplying fractions, we don't have to find a common denominator. We only do that when we're adding or subtracting. But when we're multiplying fractions, we don't need to do that. So in example 1, we've got 2/5 times 6/7. So we multiply the numerators together, 2 times 6. We multiply the denominators together, 5 times 7. We end up with 12/35. Okay, we're done. We need to check to see if we can reduce it. 12, the factors of 12 are 3 times 4, or 2 times 6, or 1 times 12. Factors of 35 are 5 times 7 and 1 times 35. They have nothing in common except 1. So that is lowest terms. We can't reduce it. Okay, example 2, we've got 1/4 times 2/3. So multiply your numerators together, 1 times 2. Multiply your denominators, 4 times 3, we get 2/12. Okay? Can we reduce 2/12? Yes, we can. Both are divisible by 2. So 2 divided by 2 is 1. 12 divided by 2 is 6. So our final correct answer is 1/6. So multiplying fractions is actually probably easier than adding fractions with unlike denominators, because you don't have to find a common denominator. So you can also reduce fractions before multiplying to make the multiplication easier. So remember when we talked about reducing fractions, I said the reason why we want to reduce fractions is because it makes multiplication easier. So if we were going to multiply 4/8 plus 3/4, now I know these numbers aren't very big, but we can reduce first. So 4/8 times 3/4. If we don't reduce first, we get 4 times 3 is 12, 4 times 8 is 32. And then we have to reduce to get 3/8. Okay, so we can do it that way. But another way of doing it to make your multiplication easier, especially if you're dealing with bigger numbers, is to reduce first. There are 2 ways to reduce. So we can look at the fractions and see if each fraction can be reduced. So 4/8 we can reduce by dividing both 4 and 8 by 4. So 4 divided by 4 is 1, 8 divided by 4 is 2, so that reduces to the fraction 1/2. 3/4 is lowest terms. We can't reduce that. So now we've got 1/2 times 3/4. So 1 times 3 is 3, 2 times 4 is 8. There's the same answer as we got the first time, but we didn't have to worry about reducing at the end. Another way of reducing is to cross reduce. So 4/8 3/4, we can reduce the 4s. Okay, so when you're cross reducing, it's numerator to denominator, not numerator to numerator. That's why we call it cross reducing. So think of a cross in the middle or an X. So we're going to reduce the numerator of the first fraction and the denominator of the second fraction. Both are divisible by 4. So 4 divided by 4 is 1. The 8 stays the same. The 3 of the second fraction stays the same, and 4 divided by 4 is 1. So then we multiply. 1 times 3 is 3. 8 times 1 is 8. And again, we end up with the same answer. So it doesn't really matter which way you do it. Whichever way works better for you. So if you just want to multiply and then reduce, that's fine. If you want to reduce first and then multiply, that's fine too. But like I said, if we're working with larger numbers, so 4/8 and 3/4, those aren't big numbers. So it's not as bad. But if you're working with bigger numbers, then sometimes it is easier to reduce first. Okay? So let's do some practice. So find the product. We've got 6/12 times 2/12. Now again, these aren't huge numbers, except for 12 times 10 is going to give you 120. It's harder to reduce when you have a big number. So let's see if we can reduce first. So 6/12. 6 I know will divide by 6, and so will 12. So 6 divided by 6 will give me 1. 12 divided by 6 will give me 2. 2/10 I know both are divisible by 2. So 2 divided by 2 is 1. 10 divided by 2 is 5. So now I multiply. 1 times 1 is 1. 2 times 5 is 10. Okay? Don't have to reduce after, can reduce first. If I do it the other way, I've got 6 times 2 is 12. 12 times 10 is 120. And now I have to reduce. Will 12 divide evenly into 120? I have to figure that out. Okay? Yes, it does. So I'm going to divide both by 12. But if you don't know that, then you're going to divide probably by 2 first, which will give you 6 over 70. And then you have to think, ooh, not 70, sorry, 6 over 60. Then can I reduce 6/60ths? So it's sometimes easier to reduce first. You end up with the same answer. Okay, number 2, 1/16 times 7/21. So I'm not going to multiply 16 by 21 if I don't have to, because that's a lot of multiplication. So can I reduce anything? Well, 1/16 I can't reduce because the 1 tells me that that's lowest terms. But 7 21s I can, because 7 divides by 7 and 21 divides by 7. So 7 divided by 7 is 1. 21 divided by 7 is 3. So now I've got 1/16 times 1/3. 1 times 1 is 1. 3 times 16 is 48. So 1/48 is my answer. Or I could do 1 times 7 is 7. 16 times 21 is whatever, giant number, and I've got to figure it out. Okay, 8/9 divided by a half. So now if I want to reduce this one first, 8, the factors of 8 are 1, 2, 4, and 8. 9, it's 1, 3, 3, and 9. So there's nothing there I can reduce. And I can't reduce a half because it's already in lowest terms. But I can reduce 8 and 2. So 8 and 2 are both divisible by 2. So 8 divided by 2 over 9 times 1 over 2 divided by 2. So I get 8 divided by 2 is 4/9 times 1 over 1. So 4/9 times 1 over 1 equals 4/9. And that's lowest terms, because 4 is divisible by 1, 2, and 4. 9 is divisible by 1, 3, and 9. And they have nothing in common except 1. Okay, number 4. We've got 11/20 times 4/14. So again, I want to reduce first because I don't want to have to multiply 20 times 14 and get a big number. Okay, so 11/20, 11 is a prime number, so I know that can't be reduced. 4/14, I know they're both divisible by 2, so I can do 11/20 times, and 4 divided by 2, 14 divided by 2 will give me 2/7. And I still got 20 times 7. I don't want to deal with that. So I can reduce further. I can cross reduce 2 and 20. So they're both divisible by 2. So 11 and 20 divided by 2 is 10. Times 2 divided by 2 is 1/7. So now I've got 11/70. And I know that I can't, that's lowest terms because, again, my top number is an 11. It's a prime number, so I can't reduce it any further. So again, instead of doing 11 times 4 is 44, and 20 times 14 is 280, and then having to reduce from there, I made it easier. Okay, number 5, 7/18 times 11/25. Okay, 7/18 I can't reduce, 11/25 I can't reduce. They are in lowest terms. 18 and 11, again, I can't reduce them because 11's a prime number. 7 and 25, can't reduce them because 7's a prime number. 25, yeah, but not 7. So this time I actually do have to do the multiplication. I can't simplify anything. So 7 times 11 is 77. Excuse me, 18 times 25 is 450. Okay, so I've got 77 over 450. So can I reduce that? Well, I know that the only numbers that will divide into 77 are 7 and 11. So then I need to say can 450 divide by 7 evenly? No. Can 450 divide by 11 evenly? No. So 77 450th, that is my answer. And sometimes you will get an answer like that, but always check and see if you can reduce first. Okay, number 6, 3/15 and 3/7. So I know 3/15 I can reduce. 3 and 15 are both divisible by 3. So 3 divided by 3 is 1. 15 divided by 3 is 5. So 1/5 times 3/7. I can't reduce 3/7, both prime numbers. So 1 times 3 is 3. 5 times 7 is 35. And can't reduce that because 35 doesn't divide evenly by 3. And number 7, 2/4 times 3/6. So I can do 2 times 3 is 6. 6 times 4 is 24. I can just multiply numerator to numerator, denominator to denominator, and then I can reduce. 6 and 24 are both divisible by 6, so I end up with 1/4. Okay, or I can reduce first. Okay, 2/4 reduces to 1/2. 3/6 also reduces to 1/2, and then I get 1/2 times 1/2, which will give me 1/4. Number 8, 5/7 times 15/18. So I want to see if I can reduce here. 5/7 prime numbers can't reduce. 15/18, they're both divisible by 3. So I've got 5/7 times 15 divided by 3 is 5. 18 divided by 3 is 6. So 5 times 5 is 25. 6 times 7 is 42. And 25 is 1, 5, and 25. And 5 will not divide evenly into 42, so my answer is 25 42s. Number 9, 4/8 divided by 3/4. I can reduce 4/8, divide top and bottom by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. 3/4 I can't reduce. 1 times 3 is 3. 2 times 4 is 8. And my answer is 3/8. Number 10, 3/11 times 5/9. Can't reduce 3/11. They're both prime numbers. Can't reduce 5/9. 5 is a prime number. But I can cross-reduce 3 and 9. So 3 divided by 3 and 9 divided by 3. So 3 divided by 3 is 1 over 11 times 5 over 9 divided by 3 is 3. 1 times 5 is 5. 11 times 3 is 33. Okay, and that's my answer. Okay, so that is how you multiply fractions. So it's always, it's whatever works better for you, obviously. But if you can reduce first, it's probably better because you're dealing with smaller numbers, and smaller numbers are often easier to work with, or they are easier to work with. And sometimes if the fraction is smaller, it's easier to reduce because we can much more easily figure out what it is to divide by rather than working with giant numbers, big numbers. Okay, so what if you're multiplying by different types of fractions? So we talked about mixed fractions, we talked about improper fractions, and we talked about proper fractions. And there's, the other ones, unit fractions, etc. So to multiply mixed fractions, first you have to change them to improper fractions. So in our example, 1 3/4 times 2 1/2, we have to change 1 3/4 to the improper fraction for 7/4. So 1 times 4 is 4, plus 3 is 7, which gives us our fraction 7/4. 2 1/2 we have to change to an improper fraction. 2 times 2 is 4, plus 1 is 5. So 5/2 is our improper fraction. Then we can multiply. Check and see if there's anything that can be reduced first. If there's not, then 7 times 5 is 35. 4 times 2 is 8. We end up with an improper fraction for our answer, which means that we have to change it to a mixed fraction. Okay, so 8 divides evenly into 35 4 times, which will give you 32. 35 take away 33, 32 is 3, so our answer is 4 3/8. Okay. If you are multiplying, let's do some examples of multiplying mixed numbers. So 4 3/7 times 4 8/9. So you can't go 4 times 4 is 16. Okay, it doesn't work that way. So 4 3/7. So 4 times 7 is 28, plus 3 is 31/7. Times 4 times 9, 36, plus 8, 44/9. And now we can multiply. Okay, so again, right here, there's nothing that we can reduce. So we need to multiply our big numbers. So 31 times 44 is 1,364 over 7 times 9 is 63. Now, we need to change this to a mixed fraction. So 63 divides into 1,364 21 times. So 21 times 63, I'm using my calculator, is 1,323. So if I subtract 1,323 from 1,364, I end up with a remainder of 41. So my answer is 21 and 41/63. And I can't reduce that because I know 41 is a prime number. Okay, so big answer. So again, that happens when you're dealing with mixed fractions. Okay, so 3 4/7 times 2 1/9. 3 times 7 is 21, plus 4 is 25 over 7, times 2 times 9 is 18, plus 1 is 19 over 9. Okay, nothing that we can reduce here, so we got to multiply. 25 times 19 is 475 over 9 times 7 is 63. So now 475 divided by 63 will give me the whole number of 7. So 7 times 63 is 441, and I subtract that one from 475, which will leave me with a remainder of 34/63. And that's lowest terms. Okay, so that's how you do mixed numbers. Now, multiplying fractions and whole numbers. So when you multiply a fraction by a whole number, you have to make that whole number into a fraction. And the way we make a whole number into a fraction is by putting it over 1. So now we have 4/8 times 16 over 1. So we can multiply 4 times 16 and 8 times 1, or we can reduce. 8 and 16, I don't know why I crossed those out, sorry. 8 divided by 8 and 16 divided by 8. So we end up with 4 over 1 times 8 over 1. 4 times 8 is 32 over 1. Our answer is the whole number 32. Because 32 divided by 1 is 32. Okay. 3/6 times 10, same thing. Put 10 over 1. And we've got 3/6 times 10 over 1. Anything we can reduce the 6 and 10 because 6 is divisible by 2 and 10 is divisible by 2 as well. So 3 over 3 times 5 over 1. 3 times 5 is 15 over 3, and our answer again is 5 because 3 divides evenly into 15 5 times. Okay, 2/3 times 2 over 1. Can't reduce anything here. 2 times 2 is 4 over 3. Our answer is 1 1/3. Okay, so that's how you do that. Take your time, make sure you follow the rules. So that brings us to key question 8, where you're going to be multiplying those numbers. And D and E are mixed fractions. Remember to change them first. And B has a negative fraction, C has a negative fraction, and F has negative fractions, as well as E actually. So be very careful. Remember, when you're multiplying by fractions, you're multiplying negative. It's like multiplying negative numbers. Same rules. So a negative times a negative is a positive. A positive times a negative will give you a negative answer. Don't forget your negative signs. Okay, so moving on. Dividing fractions. So on page 28 of your lesson is some information on dividing fractions and some examples. Page 29 has support question 11, dividing fractions. Again, take your time, do that before you move on to the key question. Okay, so dividing fractions. So dividing fractions is very similar to multiplying fractions. So basically what we do is we change a division problem to a multiplication problem. So step 1, keep the first fraction. The first fraction doesn't change. Step 2, change division to multiplication. Step 3, take the reciprocal of the divisor. So to get the reciprocal, basically invert the fraction or flip it. For example, if the fraction is 2/3, The reciprocal is 3 halves. Basically, you flip it. Then you multiply the numerators, multiply the denominators, and simplify the answer. Okay, so example, 2/5 divided by 2/3. Okay, so the first fraction stays the same, 2/5. Change division to multiplication and flip 2/3 to be 3 halves. Then you multiply. 2 times 3 is 6, 5 times 2 is 10, you get 6/10. Then you reduce. 6 divides by 2 3 times, 10 divided by 2 5 times. Okay, so 4/7 divided by 2, so you're dividing by a whole number. You have to make that whole number into a fraction first by putting it over 1. So the first fraction stays the same, 4/7. Change division to multiplication. Change 2 over 1 to a half. And then multiply. 4 times 1 is 4. 7 times 2 is 14. So we end up with 4/14, both divisible by 2. So we end up with 2/7 as our answer. Okay, so not terribly complicated, but you do have to remember to flip the divisor. Okay, so find the quotient. 4/6 divided by 3/4. So first step is keep the first fraction, then change division to multiplication, then flip the divisor. So 4/3. Okay, now I can reduce because 6 and 4 are both divisible by 2. So I can do that. So I've got 4/3 times 2/3. 2 times 4 is 8. 3 times 3 is 9. I end up with 8/9. Number 2, 1/9 divided by 11/12. So first fraction stays the same. Change division to multiplication. Change 11/12 to 12/11. Okay, and I can reduce again because 9 and 12 are both divisible by 3. So I get 1/3 times 4/11. 4 times 1 is 4. 11 times 3 is 33. And I can't reduce these fractions. That's why I'm not, because I can't. Number 3, 3/5 divided by a half. So 3/5. Division changes to multiplication. A half changes to, 2 over 1. 3 times 2 is 6. 5 times 1 is 5. Now I have an improper fraction. So I have to change this to a mixed fraction. 5 divides evenly into 6 one time with 1 left over, so 1/5 is my fraction. 6/7 divided by 2/5. First fraction stays the same. Change division to multiplication. Change my 2/5 to 5 halves, so invert the fraction. I can reduce. Divide 6 by 2 and 2 by 2. So 6 divided by 2 is 3/7 times 5 over 1. 3 times 5 is 15 over 7 times 1 is 7. So 15/7. I have to change this to a mixed number. 7 divides into 15 2 times with a remainder of 1. So 2 1/7. Okay, number 5, 6/8 divided by 5/7. So first fraction stays the same. Change division to multiplications. Change 5/7 to 7/5. Can I reduce? Nope. I could reduce 6/8. Both are divisible by 2. So I've got 3/4 times 7/5. 3 times 7 is 21. 4 times 5 is 20. Got an improper fraction. 20 divides evenly into 21 one time with a remainder of 1. So 1 1/20. Okay, let's move down to the next page and let's look at dividing mixed numbers. So same deal for dividing mixed numbers. The only difference is we have to change them to improper fractions first. So 2 1/10. 2 times 10 is 20, plus 1 will give me 21 over 10. 4 times 2 is 8, plus 1 is 9 over 2. Now, you'll notice that I haven't changed the division sign yet. Okay, division is still division because I need to make that switch to improper fractions first. Now, I will follow the rules for changing division to multiplication. So change division to multiplication, change 9 halves to 2 ninths. Okay, so 21 tenths times 2 ninths. Can I reduce? Yes. 10 and 2 are both divisible by 2, so I end up with 21 over 5 times 1 ninth. So 21 times 1 is 21, 5 times 9 is 45, and that's my answer because I can't reduce it. Okay, let's do number 2, 3 1/8 divided by 4 2/7. So 3 times 8 is 24, plus 1 will give me 25/8. Still division, because I'm still working on it. 4 times 7 is 28, plus 2 is 30/7. Now, can I reduce? 8 is divisible by 2, and 30 is divisible by 2, so I can. So I have 25. 8 divided by 2 is 4. And I'm going to, oh, wait, no, sorry, I can't. I'm getting ahead of myself. I can't do that because I forgot. I have to, see, this is what I mean by trying to do it too fast. I have to change division to multiplication first, and then 7/30ths instead of 37ths. So now can I reduce? Yes, I can, because 25 and 30 are both divisible by 5. 25 divided by 5 is 5/8 times 7. 30 divided by 5 is 6. So 5/8 times 7, 6. 5 times 7 is 35. 6 times 8 is 48. And I can't reduce any further. Okay, so that was an example of, again, why you need to do all the steps first. Take your time. Try not to skip any steps. Okay, dividing fractions in whole numbers. So here again, we need to change 13 to 13 over 1 first. Then we change division to multiplication, and we flip the divisor. So instead of 13 over 1, we're multiplying by 1/13. 1 times 1 is 1, and 9 times 13 is 117. So that's our answer. Okay, with number 2, 5/10 divided by 3, that's 3 over 1. So 5/10 times 1/3. Okay, 5 times 1 is 5. 10 times 3 is 30. Now I can reduce this because 5 is divisible by 5 and 30 is divisible by 5. 5 divided by 5 is 1. 30 divided by 5 is 6. So my answer is 1/6. So again, you always have to check and see if you can reduce. So 4 divided by 2/10, 4 over 1. So that, again, doesn't matter where it is, it doesn't change. It's still 4 over 1. Times the second fraction is the one that flips, 10 halves. So can we reduce here? Yes, because 4 is divisible by 2 and 2 is divisible by 2. So 4 divided by 2 is 2 over 1 times 10 over 1. 2 times 10 is 20 over 1. My answer is 20. Okay, so again, follow the steps. Don't try to take shortcuts. All right, so that brings us to key question 9, which is divide the following. So again, I didn't do any examples with negative numbers, but you do have negative fractions that you are multiplying. So remember the rules for multiplying negatives. All right, so that's it for our class today. So those are the last two key questions in lesson 1. So finish those up. And on Thursday in class, we will be starting lesson 2. If you have any questions, please contact me, or you can watch the class again on YouTube.